So we have the formula A equals PE to the RT. R equals rate, T time, P principal, A final amount. Given that P equals $10,000, the rate is 5%, T is 15 years, we have to find what A. Okay, so we use the formula A equals PE to the RT. A equals our P, which is $10,000. E to the R, which is 5%, so 0.5. And then T is 15 years. Okay, so then A equals 10,000. E 0.75. So A equals, what time is it, Maria?
It's time for the calculator!
Yay! It's time for the calculator. It's time for the calculator. So we put 10,000 E to the 0.75 equals 21,170.00017. That's your answer. So that's the final amount. So now we want to know, when will the initial amount be doubled? Dun dun dun! Okay, so our initial amount is $10,000. Again, we use the formula A equals PE to the RT. So we want to know how much it will be doubled. So it will be 10,000 doubled will be 20,000 equals 10,000 E to the 0.5, and we want to know how much time. So it's T. So to have this by itself, we have to divide by 10,000. Divided by 10,000. Okay, so then 20,000 divided by 10 is 2 equals E 0.05 to the T. You have to take the natural log of both sides to get rid of the E. So then the natural log of 2 equals 0.05 T. So you have to by itself divide by 0.05 on both sides. 0.05. So then T equals ln 2.05. What time is it, Maria?
It's time for the calculator. It's time for the calculator.
Okay. So then we plug it in. Natural log of 2 divided by 0.05 equals 13.8629 years. Yay! So in approximately 14 years, you will have double your amount.
So one day you're walking down the street on a beautiful day and you find a dead body laying on the ground. You're a police officer and you see that regular body temperature is 98.6 degrees Fahrenheit. And the room temperature at the time was 65 degrees Fahrenheit. So to know when this person died, you would use a Newton's law of cooling. If you follow me over here, we'll show you how. Here, A represents ambient temperature, T represents time, Y represents temperature. Here with an A equals 65 degrees Fahrenheit, our natural body temperature would be 98.6 degrees Fahrenheit. And our formula is Y equals A plus B E K to the T. What we're given is that at the time that the body was found, the temperature was 85.90 degrees Fahrenheit. At 10 minutes, the temperature was 85.17 degrees Fahrenheit. At 110, we don't know, so that's what we have to find out. So at 67 degrees Fahrenheit, we must know the time. For here, we start by writing our equation. Y equals A plus B E K T. We plug it in. Y, our temperature, 85.90 degrees equals 65 from our ambient temperature plus B, because we don't know our B yet, e to the K0, that's our time, our T. Here, this gets canceled out, and we're left only with 85.90 equals 65 plus B. We subtract 65 from both sides, and we're left with 20.9 equals B. So then we follow to our next arrow to continue. We already know our B, so we'd be able to plug it in. So our new Y would be 85.17 equals 65, our ambient temperature, plus 20, our B, 10, our T, times K, which is what we'll be finding today. So we subtract 65 from both sides. This dies, and we're left with 20.17 equals 20.910K. To leave 10K alone, we divide by 20.9, divide by 20.9, and we're left with 20.17 divided by 20.9 equals E10K. To get rid of that, we take the natural log to both sides, and we're left with natural log of 20.17 divided by 20.9 equals 10K. To leave our K alone, we would divide by 10, divide by 10. Follow a beautiful arrow up here, and our K equals the natural log of 20.17 divided by 20.9 all over 10. So now, do y'all know what time it is for?
It's time for the calculator. It's time for the calculator. It's time for the calculator.
So as we plug this into the calculator, natural log of 20.17 divided by 20.9 divided by 10 gives us our K. K is equal to 0.0035552. But wait, there's more! So now, we would want to find what the temperature of the body was at 110 minutes. So we put Y equals 65, our room temperature, plus 20.90, our B, E to negative 0.003555281, which is our newly found K, times 110. So now, Anna, what are we doing?
It's time for the calculator. It's time for the calculator. 65 plus 20.90, second E, memory A, which is our K, times 110, equals 79.1352202 degrees Fahrenheit at 110 minutes.
We can now move on to see at what time the body was 67 degrees Fahrenheit. At 67 equals 65, our ambient room temperature, and plus 20.90 E to negative 0.003555281 times our T. We subtract 65 from both sides. These cancel out, and you're left with 2 equals 20.9 e negative 0.003555281 t. Now we divide by 20.9. Divided by 20.9 to both sides. These cancel, and you're left with 2 divided by 20.9 equals e negative 0.003555281 or k times t. You take the natural log of both sides, and you're left with natural log of 2 over 20.9 equals negative 0.003555281 t. To get t alone, we divide by negative 0.003555281 to both sides. Anna, so what time is it for?
It's time for the calculator. It's time for the calculator. Okay, so then natural log of 2 over 20.9 equals, we store it, so then the b divided by this number we had already stored it as a equals t equals 660.0328289, or approximately 11 hours.
So how long ago did this person die? Well, let's find out. Normal room body temperature is 98.6. Our room temperature was 65 plus 20.9, or B, e to negative 0.035, you know the rest, times T. To get this, you subtract 65 from both sides. You're left with 33.6 equals 20.9 e negative 0.00355 blah blah blah, you know the rest, times t. You divide by 20.9 to both sides. And you're left with 33.6 divided by 20.9 equals e to negative 0.003555281 t. You take the natural log to both sides, and you're left with natural log of 33.6 divided by 20.9 equals negative 0.003555281 times t. To get our t alone, you divide by our k to both sides, 0.003555281. And finally, you know what time it is again.
It's time for the calculator. It's time for the calculator.
So you take the natural log of 33.6 divided by 20.9, which equals, store it as c. You put your c divided by your k, which is stored as a, and you get t equals negative 133.5413285. T equals natural log of 33.6 divided by 20.9 all over our k, negative 0.003555281. So approximately our poor little guy, he died around 2 hours ago. Sad story. Now make me a sandwich. Dun dun dun.
Okay, so we're taking derivatives. We have the equation f of x equals 3x squared plus 10 squared. Okay, so then you rewrite the equation 3x squared plus 10. You ready to times since it's squared plus 10. You have to distribute. So this one. So you distribute, so it will be 9x to the fourth plus 30x squared plus 30x squared plus 20. So it equals 9x to the fourth plus 60, because 30 times 30 is 60. 60x squared plus 20. You don't want to do the calculator? Yeah. So then it equals 9, 4x, 4 minus 1, because we have our power rule. F of x equals x to the n, where n is a rational number. Then derivative of f of x equals n times x, n minus 1. So that's what we have here. We do the same thing over here. Times 2, because our number is 2, so then x 2 minus 1 plus 0. The 20 converts to a 0 because that's a constant rule. The derivative of a constant is 0. So
it's time for the calculator.
No, Maria, no.
Okay. No. Calculator.
No. You don't need calculator for derivatives. Sorry about that. So our answer is derivative of f of x equals 36x cubed plus 120x. That's how you take a derivative.
We're gonna be doing the chain rule since we can't use a calculator.
Oh, no calculator.
When we have the function g of h of x, you take the derivative by taking the derivative of g times the inside hx times the derivative of the inside. So when we have the function x plus 2 to the fourth, we take the derivative by having f of x equals, you multiply the outside first, so it'd be 4 times the inside, x plus 2 cubed, because it's 4 minus 1, times 1, because when you take the derivative of the inside, this cancels out because of the constant rule, it becomes a 0, and then right here 1 minus 1 is 0, so this becomes a 1. So we simplify it, and our answer is 4 times x plus 2 cubed. If you still didn't get that, we have another chance to get it. When we have the function of x, 3x cubed minus 5x to the 10, we take the derivative by doing the outside, so it'd be 10 times the inside, 3x cubed minus 5x, 9, because it's 10 minus 1, times the derivative of the inside. 3 times 3 is 9. X cubed, 3 times that is like x squared, minus 5. When you simplify that, you can't distribute the 10 into this one because I'll have an exponent 9 here, so you distribute it to this one. 10 times 9 is 90, x squared, minus 10 times 5, 50. And then you just bring this down. So 9. And that's our chain rule.